flooding of a large amount of water beyond its normal limits. It is a natural event or occurrence where a piece of land in that area, usually dry land, suddenly gets submerged underwater. Some floods can occur suddenly and back to normal quickly. Others take days or even months to build and discharge. Flooding is extremely dangerous and has the potential to wipe away an entire city and can cause extensive damage to life and property. Our problem statement is that the risk of dam overflow failure has received increasing attention in recent years. This risk assessment is important in the determination of the dimension of spillways, their satisfactory operation, and in the assessment of dam and safety and investment. Due to lack of research in the making of water pass around the village is one of the factors of flooding. But the occurrence of rain also can cause water dam to break and also can cause of the flood. Therefore, this study is to measure the uncertainty influence of various random factors to the reservoir level of hydrograph.
Today I would like to talk about objective of study. They have two objectives of study. First, to describe and estimate the stochastic reservoir level hydrograph in a flood routing process. Second, to analyze a stochastic reservoir routing process, a stochastic differential equation with a stochastic input time and a random initial condition.
In this project, we want to analyze a stochastic reservoir routing process. A stochastic differential equation with a stochastic input term and a random initial condition must be presented. Stochastic variation is a storage value that temporarily occupied by a fluid. Then, stochastic reservoir level hydrograph are controlled by the stochastic inflow and outflow hydrograph. The process can be investigated as first, the stochastic inflow design flood. Assume that the stochastic process is normal, mean given by the IDF hydrograph. Second, the stochastic outflow hydrograph. The outflow is to be regarded as a stochastic process. In this procedure, there is only one independent variable C to cause the random variation. Third, the stochastic available storage curve. The stochastic is normal, mean given by the WH curve from the standard design process. It specifies the definition condition of Brownian motion. Linear process zero mean can be founded from the expectation hydrograph of the storage value. Brownian motion is proposed to describe the characteristic of reservoir storage capacity in flood regulation, and itu stochastic differential equation, including a random input term, is proposed to describe and estimate the stochastic of reservoir level hydrograph in a flood routing process.
Our group want to explain which part does white noise take place and what is the white noise for this research. The three stochastic input process are considered independent. We can find the standard deviation of the variance capital Q, small q and W at time t, which we can determine from the observed data. The variance synthesis the effect of capital Q and small q and W on Brownian motion. The initial condition H0 in this equation can be assumed either deterministic or random. Normally, at the beginning of a routing process, the reservoir level has uncertainty. It means value H0 can be determined from a flood control level. The derivative of D and over derivative T is the representation of the white noise from Brownian motion in this equation.
Hi, I would like to explain for the stochastic differential equation which involves the disturbance of noises. It may be said without fear of contradiction that the equation dW over dm equals to gm. It is the equation that involves the disturbance of noises, which leads to the overtopping risk in the flood routing process. Overtopping occurs when the maximum reservoir level exceeds the level of the dam crest, and m equals to the exceedance of m. And it is convenient to divide the difference of m between the maximum reservoir level h and the level of dam crest depth, and m equals to h minus z. And for the level of the risk of overtopping, it is considered as the probability of the existence of m equals to 0. And for the equation Pf equals to Pf, h greater or equals to z, Pf is the probability of the occurrence of overtopping. And next, for the risk assessment, they are significantly affected by the stochastic factor of z and h. And for the random characteristic of z, it is influenced by the scale of elevation of the dam crust during the construction. And lastly, it is often assumed that the random variable z is normal, with mean given by the design elevation of dam crust and a small standard deviation. Next, I would like to explain the solution for the stochastic differential equation, which involve for the disturbance of noises. Before beginning the risk analysis of overtopping failure, a review should be made of any available design record of the dam and spillway, and the uncertainties of data of stochastic variables such as z and h should be examined. Next, for the stochastic process of the reservoir level, with a series of density functions obtained by solving the equation. And besides that, it depends on the combined effect of various random factors taken into the consideration in the procedure for analyzing the uncertainty of h bracket f. And for the density function of h bracket t, which is one of the basic variables in equation, cannot be assumed normal. And lastly, to improve the accuracy of the risk assessment, the second moment method and outline may be employed. Thank you.
For the brief summary, to sum up, for the hydrograph QT, when the effluent discharge Q is less than 3000 m3 as negative when no our facilities operate. When Q is between 3000 and 6300 m3 as negative one, a peak inflow of for a 20 years old, the outflow discharge Q is 3000 m3 as negative one. When Q is bigger than 6300 m squared as negative 1, all outlet facilities operate fully. The conclusion are, the model used to describe and estimate the stochastic reservoir level hydrograph in a flood building process is very important in order to reduce the risk of dam overtopping failure, which have received increasing attention in these years. As the risk assessment is important in the determination of the dimension of spillways, their satisfactory operation, and in the assessment of dam safety and investment. Since the model is designed, the analytical process can be done accurately to minimize the uncertainty, influence of various random factors on the reservoir level of hydrograph.